Hi everyone, welcome to my channel. Today I'm gonna show you how to plot these two graphs A and B. The first one is a heat map for genotype and environment interaction analysis, and the second one is line plot for genotype and environment interaction analysis. This question is arise from one of my YouTube followers, so I will address the codes and also the solution for the question. So let's go to our other software, and in order to compute heat map and line plot for genotype and environmental interaction analysis, you have to use the methane package. So submit this one, and again, the data that we're going to use for this tutorial is the data underscore GE2, which is built in the methane package. So let's see the structure and the environment, the genotype, and the replication should be in a factor. So let's check. Yeah, it's already it's a factor, so no need to convert into factor. But in case if your data is not a factor, or maybe it's numeric, maybe it is character, you should have to change into factor in order to get the correct or appropriate plot. Otherwise, it will give you another result. So by this way, you can check and also convert your uh, treatment using as dot factor function, and you can check one of my tutorial regarding that. So let's draw a heat map for genotype and environment. To do this, you have to use the GE underscore plot, which is again built in the methane package, and this followed by the data name. Then it's followed by the column that contains the environment, the column that contains the genotype, and the column that contain the response variable. In our case, I used here is planted. Maybe for you is different due grain yield, above ground biomass, or number of seed, blah blah. So for me is planted, and type is equals to 1 that I'm going to, or you will get the heat map, and when you say type is equals to 2, you will get the line plot. So later I will show you. Then the value is equals to false. This helps us to get rid any values that display in a heat map. Let's show you first. Let's say here is true. Then again, average is equal to false, means it discards the average value from the heat map. But if you say true, it will display the average result. Then the text and underscore row underscore position, it will give you only two options, either in the right or in the left side. So I prefer the left one, and again the x-axis title and the y-axis title. So x-axis title is environment, is obvious, and again the y-axis title is the genotype. So by this way you can perform or you can give a title for both x and y-axis. Then the color position, again, it will give you two positions, either at top or bottom. So let's run the methane package. Okay, already we did. Then let this one, let them see the graph. Yes, as you can see here is the genotype, and again here is the environment. But also the problem here is the average value here. Again, the average value is here. And again, inside the heat map, there is a value. This is all this value is 2.5, 2.6. The reason why it's displayed here because we said it is true, and the average also we said is true. So, but if you want to discard both the values that found in the heat map and in the environment, so you have to specify here into what? Into false. Into false, again into false. False. Then, as you can see, here is the position displayed in the left, but if you are not interested in that one, you have to change into right. And again, here is the environment is displayed in the bottom, but if you want into the top, so you have to do that one. Yes, you can get again such a result. But which one is best? I think the right, the left, and the bottom one, or let's make here, yes, the bottom one is good. Yes. Then we get rid everything, the value that found in the heat map, the average values for both direction. So by this way, we can compute or we can draw a heat map for genotype by environmental interaction analysis in methane package. But if you want to give a title, the question that raised is this one. If you want to display this one, so you have to relay in the ggplot package because the ggtitle function is dependent on ggplot package. So let's say A is what created here, or A is this graph, then plus the name is maybe GY, maybe since it is planted, let's say it's pH, then do this one. The vertical adjustment helps you to display the pH legend name around this. For example, let's show you, let's type this and let's show you. Yeah. Yes, as you can see, it's displayed here. But when we save this plot using digital function, it will give you a good result. And there is no overlapping of this pH name. Let's show you. Let's say this one pH. Yes, let's keep the pH, the file name. And the plot, what we created here is W. So we have to convert HU into W. Then the width is 15 centimeter. You can increase 20 or 25 centimeter. That's depend on the size that you want. And again, height is 15 centimeter. In similar fashion, you can do or you can change the height up to 20, 25 or 30. And the DPI or the pixel quality is 3000 and the unit is in centimeter and the background is to give white background. So you have to use this one. So let's run this. And still it's in the process because this sign indicates that the error is under the process, so no need to load anything. It's better to be patient. So still, yeah. So the name of our graph is pH. So let's go to document. Yes, let's go to document, then pH. Yeah. So it will give you this heat map for genotype and environmental interaction analysis for the plant. Hey, let's continue for a line plot. So in order to do a line plot, it is similar to the heat map, but what makes it different from it is by saying or by specifying this. So when you say type is equals to 2, you want to do for line plot, and when you type is equals to 1 for what? For the heat map. Then let us assign a name B, and here is the function is the same, and it's followed by the data name and followed by the column that contains the environment column that contains the genotype column that contains the response variable, and here is type is equals to 2, so it will give you the line plot, and the value is equals to false, average is equals to null, and there is a position is left, so the x-axis and the y-axis are planted, and the text color position is bottom. So submit this one and you will get this result. Let's run B. Yeah, this result. So as you can see, there is the genotypes, 10 genotypes, and again there is 4 environments and the value of plant height. So by this way, you can compute the line plot for genotype by environmental interaction analysis in our software. But this is not as attractive. But if you want to make more attractive, you have to use different terms. For example, let's use this one. Term is called so classic. There are a number of ways that are going to help you to good image. For example, let's term classic, or maybe stem underscore BW. Yes. Yeah. Again, there are a number of methods. Maybe stem underscore dark. If I'm interested in dark, it will give you all this result. So whatever it is. So let's say this ZZ is equals to, and I want this one, or instead classic is better. Yeah, classic. Then let's have this one. Yes, classic. Then the file name, let us assign LL line plot or LP line plot. Then this is what ZZ. Yeah, let's wait the result. Yeah, so our name is LP, so go to document, then here is LP. Yes, so by this way we can compute for heat map as well as for line plot for genotype by environmental data related or experiment issues. So this is all about today's tutorial regarding to heat map and line plot in genotype by environmental interaction analysis in our software, more specifically in meta package. So I'll put the code in description or comment box for your practice. Thank you for watching. Have a nice time.